everything you can hear. 100% infield. Huge thing here. This is also on island. I mean, can you even see it 3D printed? Oh no, even play around. It's very nice. So we are in the lab. 40mm tube. Whoa. Be mine. All our different materials. How do you guys like this? I think we are live. Hey, awesome people, how are you? Doom crewing, how are you? Computer medic, just make a chewy, almighty. Only Twitch today. Let me check. Oh, Joe Velasco on YouTube, how are you? Dave on YouTube as well, how are you? Hey, Zombie 3D Experiment, Tactile 3D, Valandar on YouTube as well. What is this going to be? Today, Printbusters is about input shaping. Did I put it on the title? Oh, no, I didn't put it on the title. Yeah, mainly because if I put it on the title, then I have to stick to it. But if I don't put anything in the title, then we can have a little bit of tangent as well. Hey, Peslis, how are you? Oh, Peslis, I'm actually writing a message to you. I need your help for the Canada website. I need someone in Canada to place a first order using a coupon to test the website before it goes live next week. So I was about to write a message and then I had to start the stream. Oh, from Thailand, Jayo Kachione. How are you from Thailand? Oh, so you are pretty much on the same time zone as me. Family is great and healthy, Yabajak. Thank you for asking. First time following Louis Red. How are you? Thank you for joining. Thank you for joining. You need black ASA, Mike Schmidt. Where are you? Are you in the US, Canada, Europe? We should have black ASA except in Canada, but the rest should have it. Oh, okay. You are in Canada. Okay. Let me know if you want to see some input shape. Oh, Zombie, did I send you the link? If you want to join, maybe I didn't. Let me send you, and if you have time, of course, feel free to join as always. Oh, I just saw your message. Yeah, you will need to send me an invoice. I will send you a template to make it easier. You have a lot of Canadian on your stream, usually plenty to pick from. Yeah, that's true. I noticed that. Actually, I created a group on Discord. Let me show you. So I know we have a pretty international community, or maybe not community, because on Discord we're still mainly US, I think US based people, but in terms of customers, we're very international. So I want to attract a little bit more people outside the US, and I created this thing with different channels for different languages. And the funny thing is, I created the French language with the French flag, but I think there is like 99% is Canadian people inside, like from Quebec. So it's it was funny. Like at the beginning, I put the flag, and then I saw more Quebec flag than the French flag. So it was anyway. It was funny. So yeah, welcoming everyone. Today is a Printbuster, so today we're gonna go a little bit in depth, the same way we did with Pressure Advance. If you remember well, you know, Pressure Advance, we brought out Excel files, and then we did some calculations, and we followed a video from Eddie, I think it was his name. So it was nice. I created the French language. You heard this. I created the French language. Yeah, I created a French channel. Sorry. So anyway, shifting over to Twitch. Yes, welcome to Twitch, Valanda. And there you go, Valanda the Red. Okay, I guess that's you. So yeah, I mean, there is more people on Twitch. There is more fun in terms of comments and stuff, and maybe emojis or something like this. But of course, I will continue streaming on YouTube. So anyway, I think most of you know what input shaping is. Oh, I see a lot of people are going to the language channels. So we have some German people, French people, Dutch people, at least Dutch-speaking people, French-speaking people, German-speaking people. That's nice. Yeah. If you are if English is not your native language and one of your native language is there, then feel free to go and check out. It's always nice, like the I don't know if American has this feeling because it's English, but for example, I'm French and I live in China, and when I see someone else speaking French, there is this type of relationship already, even if we don't know each other. And then I mean, there is like maybe 60 million people in France, right? But just the fact that we speak the same language that is not too much universal like English, then it creates that connection. So I think it's what's happening a little bit when you go on a Discord and everything is English, and then suddenly you have a little bit of your native language, then it creates that type of connection. Anyway, I don't know if you have that feeling, but I definitely have when I go to overseas and I see people speaking the same native language as me, then I have that feeling. Okay, Zombie, I barely speak English. Not really English is spoken so much around the world. It's never an issue like that. Yeah, I know you're awesome. Oh yeah. Speaking about awesome printed vision, how about we at least get our giveaway started before we dive into input shaping. And by the way, I didn't do any research on input shaping. I kind of know what it is. Like some type of thing that is happening on your printer that prevents artifacts from vibration or something like this. So I roughly know what it is. Like generally, I know what it is, input shaping, but I have no idea how it works. I've seen people doing some input shaping test, and then they post some kind of strange graph on the Discord. I have no idea what this graph means or whatever. So we're going to learn from scratch, basically. Or I will learn from scratch, and hopefully I will catch up with some of you, and then we'll continue learning together. Okay, so I aspire to be awesome. You're all awesome, guys. You're all awesome. And you know what? I really love, for example, just before the stream, we had this person, Wutai, that joined our Discord. And of course, every time someone joins our Discord, we welcome these people. I mean, you can see the number of welcome and even some kickstart of discussion in the welcome channel. We welcome everyone, and I was very pleased to see that. So he said, I'm happy because I finally get greeted on a Discord server. So I'm very happy that our Discord is standing out a little bit by being very friendly and very awesome. And that's why my giveaway is always I'm awesome, because I want everyone to realize that. And this type of message really makes me proud that we have built such an amazing community. Okay, I can run in input shape a fresh graph for you. Yeah, Chewy. Actually, why not? That will avoid me to go and look for the input shaping graph that I saw before. So anyway, what I usually do when I want to start learning about something is I usually go on YouTube first and Google second. I know some people do the opposite, but I usually go on YouTube first and see if there is anyone that has a great foundation on the explanation of input shaping or input shaper. Apparently, input shaper. Okay, and usually what's going to happen is most of the YouTube video is going to be on the very surface, like how to install Input Shaper, or or what is the result of before and after Input Shaper, but there will rarely be videos that will actually explain what input shaping is and what it does, and that's the hard part, and that's why we'll have to figure out by yourself, kind of by ourselves. So maybe we can try Eddie the engineer. Is it Eddie the engineer or Eddie engineer? So I think Eddie the engineer. So this guy go pretty much in detail. I mean, he has excellent videos, and I think hopefully he did something with input shaping. So we were inspired by his pressure advance video to do our Printbusters, but looks like he doesn't have input, just input. Input shaper. Okay, so he does have one. Bell tension resonance, clipper input shaper update. So that was from 2 years ago. I heard about input shaper like a few months ago, like maybe mid 2022, and this guy was already explaining what is input shaper 2 years ago. So let me open some of these videos, and maybe here's a question. Do you think so the issue we are going to try to solve, I guess, let me know, is it only ringing, ringing, ghosting, this kind of thing? Is that the only thing that input shaper is helping with? Let me show you, like ringing 3D printing. Okay, so I guess most of you knows, but just to show you, so this issue, okay, so this is caused, or let me know it's caused by what, because a lot of people say it's because of vibration, but for me, if we go back to the basic, we don't care if the printer is vibrating or not. It's, for me, it's about something else, which is related, but I don't think vibration is the actual explanation for that. So sorry, I don't know if you are hearing the firecrackers, but in China, every time something opens, and pretty much every day something opens, then there is firecrackers everywhere. But anyway, so first question, does input shaping help only for this, like to go from no ringing, from ringing to no ringing, or is there anything else it helps with? So that's the first question that you can try to answer in the chat. And the second question is, what is actually causing the ringing? Is it just the fact that the printer here, what? Is it just the fact that the printer is vibrating, or something else? So what do you guys think? Valender the Red, it's not vibration. My system is on 16 by 16 by 2 inch paving stone, and that is on top of a one dense foam pad. I can put a BB, I don't know what is BB, on the paving stone when I'm printing, and it won't start rolling. Okay, it's not vibration, resonance, compensation. Okay. See you soon, Zombie. Movement of the head or the hot end. Okay, I mean, it's moving already, right? I mean, when you're printing, it's moving. So I'd like to learn input shaping in RRF, vs Clipper, and recently Marling. Oh, you mean there is different way of doing input shaping? Like the RipRap firmware do it in one way, and Clipper doing it in one way, and Marling do it in a different way? I didn't know that. So I guess we'll focus on Clipper, because that's the name of the video. This is like the collapsed bridge in the United States, the resonance frequency. Okay. There's still resonance in the printer, even when a solid surface. Yeah, but where, if you had, okay, so let me give you my explanation on where does the ringing come from, or at least the logic I have. For me is, why am I saying is not really the printer vibrating? is because, for me, what I think it is the printer is bending or is deforming. That's the cause of ringing or whatever, ghosting or whatever you call that. Because vibrating doesn't matter, right? You can put it on a big spring, and then when it's printing, it's going all over the place. But that doesn't matter. It's not going to affect the quality of the print. What's going to affect the quality of the print is the part that are bending. So, like, I don't know if you can see. Yeah, like this. So it's the fact that it's going to bend. Like this one is going to bend there, and then this bend there, and then this bend here. So everything is going to deform, and that's going to cause the ringing. So why it is related to vibration in a way that vibration is going to move the printer, but the real issue is that it's not going to move the printer uniformly, right? So it's going to move. So this one is going to go at a certain speed in that direction, and then it's going to suddenly stop, and then it will first move this, but it's not going to move the bed. Okay, it's only going to move that part. So the issue is that it's going to deform. You get what I mean? So that's why the you have the ringing, right? And then it's going to come back and then deform and then come back. So that's my explanation of why resonance and this type of thing. I don't know if it's the core explanation. For me, the core explanation is the fact that the printer is not a solid system, right? It's something that deform. That's the cause. If whatever you have, resonance, vibration, all of this, if you have a printer that doesn't deform, you don't care about resonance and vibration or something like this. Or at least that's how I think. But I'm thinking on the go right now. I'm just trying to learn at the same time as you. So what do you think about this explanation? Because I see a lot of resonance, vibration, belt tightening, this kind of thing. So, but for me, the core is really the fact that a printer is flexible. That's the core of the problem. NSCHO, I posted a video on the Discord before that explained this and the input shaping graph quite well. Do you mind? Is that hard to find in NSCHO, or do you have some keyword that I can search on Discord so that we can check it out? Hi, Dennis. How are you? Matt German. I've always heard it was compensation for acceleration and deceleration of the bed and extruder. Yes, I guess what input shaping is actually doing may be related to this, Valander the Red. But I just want to go step by step. Like, what is the problem? What is the cause of the problem? And how input shaping is solving this. What are they modifying, and etc. etc. So yeah, sorry for all the new one. But in Printbusters, I always go back to the very, very basic. Like you cannot go more basic than that. Let me check. Blah, blah. There are still resonance in the printer even when on the solid surface. Yes, actually, the solid surface is going to be the issue, because, for example, another debate is whether you put foaming feet, like foam feet, like flexible pad underneath, whether it's going to help or not. Theoretically, for me, I would say yes. Why? Because let's say the print head is moving very fast on that direction. Then it's going to suddenly stop or change direction. Then it's going to push the printer this way. But if the printer rests on a very solid surface and it's stuck to the surface, then it's going to deform this way, right? The whole printer is going to deform that way. But let's say the printer is on foam or it's on a flexible pad, then all that force will be the whole printer will be able to move on the side. Then you won't have that ghosting issue. I mean, depending on the pad you have. But again, it's not about resonance. It's not about vibration. It's about the printer flexing. It's about the printer deforming. It's like the collapse bridge in United States, the resonance frequency. Yeah, but let me think. I think resonance is this for me. I mean, why resonance can be a problem, can break things. If you take a cup, I don't have a cup, but like a crystal cup or something like this. So if you you know the cup, like the wine cup or something like this, then if you make it vibrate to the frequency of resonance of the glass, then what's going to happen is that it's going to gain in amplitude, because you are matching the frequency of resonance. And the problem when you match the frequency, that is that it will easily gain in amplitude, and once the amplitude is too high, then it will break. So it's about the problem that the material is deforming, and it will break because it will deform over a certain point, over the strength of the material. So that's the issue of resonance, right? Resonance itself is not a problem. I mean, you can put the whole printer as resonance. It doesn't really matter, right? What matters is the amplitude is gonna increase more and more, and then it's gonna go above the point of failure, basically, or at least that's how I understand it. When I put, hey, Subsector 3D, how are you? I saw your ticket this morning. I reached out to Kevin, but not the other one yet. I just came back on Monday, but I'm catching up, Subsector 3D. I saw your ticket. I don't know if you send me a Discord DM, because I think I reached the limitation of notification in the Discord DM, so I really need to go one by one, because during 1 week I was very slow when I was on holiday. When I put dampener on my CR10 NEMA steppers, much of my ghosting went away. Yeah, the push pull of movement come from the steppers. Yeah, agreed. Blah blah. Oh, thank you, Anestio. Let me check. Let me open that. So, by the way, if any of you disagree or would like to add more detail or more explanation on this, let me know. Right. So again, we are discussing where that ringing come from, because if you go on it or something like this, and you ask them about this, they will all answer about that vibration resonance stuff. But I think if you really look at the core, then it helps you solving the problem. The same way as warping, right? When we really look at what exactly cause warping, then it helps you much more solving the issue, right? I won't start the debate on where warping come from, but it helps you solve the problem. So I want to do the same thing here. I want to see exactly where that problem come from, and then we'll try to find some ways. Like, for example, will input shaper be useful if the printer cannot bend or cannot flex, right? Maybe no, maybe it's useless, right? Or will input shaper be useful if you just add a foam on the feet, right? Maybe it can be useless, right? So if we really know the core of the problem, then we can define all the solutions, and then we can just go for the most cost effective or the easiest to implement. Because I think input shaper, well, now it's on Marlin and RipWrap, like Enes just said, but if it was on Clipper, and then you need to invest in a Pi and then blah blah blah, so it might not be the most cost effective way of getting rid of your ghosting. But again, I haven't seen any answers to my first question. But does input shaping only help with ghosting? Because we are only talking about ghosting problem, but I don't know. Maybe input shaper is helping with something else, which I don't know. But as far as I know, it's only helping with this problem, with the ghosting problem. And actually, if you check some, sorry. if you check some videos, it's the same. You see, they only talk about ghosting. So if input shaper is really only useful for ringing and ghosting, then there might be some other way to solve it. Okay, so let's have a look at. It's a 30 minutes video, NSGO. That's gonna transform into a 10-hour stream. Can you confirm you can hear like this? Can you hear the sound of the YouTube video? Because sometimes you cannot. Now the frame is too stiff, and I think is good and bad. We need a little bit of flex to compensate it. It's just a personal theory. So what? Let me think. The frame is too stiff, and I think it's good and bad. We need a little bit of flex to compensate. Compensate what? What numeric? Oh, no audio? If I do this, you don't hear anything? Oh, no audio? Oh, sometimes it does like this. I need to do something like this. Little bit annoying that I need to do that. I need to share a window. If I share a window, let me check. Oh no. If I share a Chrome tab. If I share a window, okay, let's try again. How about now? Still no? No? Okay. Then it means I have to share the tab. So I have to share it. What's the name of the tab? How to read analysis, blah, blah, blah. Okay, so I have to do it this way. Okay, now you should be able to hear.
Parts on how which are necessary to operate our printers, less on the technical details behind it.
Okay. Can you just confirm you should be able to hear now, right?
As you may have noticed, this.
Okay, great. What I was talking about, yeah, Numeric was saying something. Yeah, so what would be the issue of the frame being too stiff? Because if the frame flex, like I said, the root cause of the ringing and ghosting is the printer flex, the printer deform. So why would we want more flex? What would be yeah, if it's, let's say, completely stiff, it cannot move, then it cannot flex, then you won't have any ringing or ghosting issue, right? So is the issue breaking? So we prefer the printer to flex instead of breaking. So that's why we wanted a little bit of flex. Is that the reason why we because you are talking about compensating, but I don't understand what compensation you're talking about. With my experiments, it occurs when my printer is too cool. I raise the temperature and the vibration lines disappear. Oh, that's interesting. When my print is too cool. Oh, maybe it could be related to the fact that if your polymer is at high temperature, then it will reshape. Maybe it will follow the nozzle. You know, when you're printing, if the bottom layer are very cold and the top layer will start to vibrate like this, deform, then if it's too cool, then it's not going to follow or something like this. But yeah, I've never heard that. That's interesting. A completely stiff printer with a motion system is impossible. A completely stiff printer with a motion system is impossible. You mean from I mean, theoretically, I guess it's possible, right? What you're saying is practically is impossible. Like we would need everything to be, there will always be a tiny bit of flex, right? That's what you're saying, I guess. I will try to explain it. It is common in construction to leave gaps and to put space and cushion for a certain rigidity, but at the same time, that is not too rigid, so with certain flexibility, the construction is more stable. Yeah, I mean, I get what you mean, numeric. So it's about the, yeah. So I guess it joined what I just said, right? You prefer the printer to flex or to absorb shock instead of breaking. So that's why you're adding that flexibility stuff. So when you're saying compensating, I guess you're saying all the shock that is going to receive, like the sudden change in speed or this kind of thing, then you prefer the printer to just deform instead of it completely breaks. Then your printer is out of. Yeah, I understand. So I guess that's and the ghosting don't appears too much. Exactly. Yeah. So I guess that's the compromise. We need enough flex for the printer to be durable, right? To not break at the first movement change. But at the same time, we don't want it to be too flexible because otherwise your print will look very deformed. Okay. Yeah, I got it. Okay, so let's see what this video is about. So how to read and analyze input shaper graph generated by Clipper. Okay. So let's see if he's going back a little bit to what is input shaper.
This video is marked as contains paid advertisement. This is due to the fact that we launched a web shop for 3D printer related things. Small giveaway point where we have a...
Okay, yeah, so now I remember. So this is the type of chart that I've seen on Discord. I have no idea how to read that chart. Like there is things everywhere, and then power, spectral density, frequency, shaper, vibration, reduction ratio, and a couple of so let's try to learn about this.
Generated our graphs, how to generate those graphs. There are additional sources in the internet. I won't do another video on that because there are, I think Nero did one, Teaching Tech did one, and a few others did. And there's also, of course, the documentation by Clipper how to generate those with retros. It's really easy. There's even a macro with a button to generate it. So no need that I go into this much further. So now we have generated those graphs, and the question is, what can this graph actually tell us?
Okay, let's go to the, I think he's going back after. We'll come back to this one.
Okay, before we go back to the graphs, I want to talk a little bit about resonances in a printer and how they are measured during the resonance measurement of Clipper. So first of all...
Okay, resonance. So we're going to talk about resonance.
Let's construct a very simple axis, which would be similar to maybe the x-axis of a V-minion. This is a motor here. This is the idler. Then we have a belt running completely around and to some kind of print head.
Let me know if the sun is not...
and now if we rotate the motor in, let's say, this direction, we move the print head in this direction. And when we do the measurement thing, we do nothing else than shaking the printer along a defined axis and measuring how the printhead actually moves with an acceleration sensor. Here, this acceleration sensor compares the actual movement with the one we would expect from this movement of the motor, and therefore is able to see at which frequencies our printer resonates. So let's look at the printer design and how it would resonate. So this is a very simple printer design, which is a separate axis and no coupling between the axes.
I saw you sent me some project or something. I think you have a link, a partner link, right? Or did I should have sent you a partner link if you need some material or project, if you have some projects or something,
and
if you need some spools, for example.
We can think of two different kinds of oscillators. One is a linear oscillator, which just means, which is usually the simplest one, is a spring with a mass attached. And this is...
Yeah, you can use the same, Steven.
It's a simple oscillator. We give it some energy by just expanding it, and then it will start going up and
I will
down.
change it
a
maybe
specific
in 1
frequency.
or 2 months.
This is the simplest
But I will
linear
update
oscillator.
all the partners.
Linear means that the counterforce to pulling on it is linear to the displacement. And that is what we basically assume within the printer. We assume a bunch of those. And now what is really interesting, they can be coupled or not coupled, which basically means if we have 2 or more of those kind of oscillators within the printer, they can do some nasty things, like when they are influencing each other, and we expand it by a millimeter due to force, it will have a force x to the center, and if we expand it by 2 millimeters, it will be.
Oh, custom creation, you don't have the link? Yeah, I receive a lot of messages, so that's why I created all of these links to make it easier to manage. But custom creation, you should have the link also, right?
2 times this force. So for a printer designed like this, which is a Cartesian printer, we have ideally 1 resonance frequency per axis, which is defined by the length of the belts and the weight which is attached to it.
Oh, you didn't get it?
Name the printhead or the print bed on a Cartesian.
Let me send it to you.
Think of a Core XY printer. We'll draw the gantry basically of a V Core 3 from viewing from the top. So this one is X, this one is the Y direction. We have our printhead here, and we have 2 belts. One belt is going like that.
I'll just send it to you. Yeah, I don't know if this let me see.
What input shaper does is basically avoiding those frequencies. So let's assume we want to how the resonances are measured on the printer with the acceleration sensor. But what actually happens when we apply an input shaper is not that we are. From this, we can already deduct how a perfect resonance profile would look of our printers, like a Cartesian or a Core XY. So before we now go to have a look at the shaper graphs themselves.
Yeah, I think it's too long. Let me see if this one will be a bit better. 3D printer mechanic belt tension and resonance. With this input shaper test, it is just about automatic now, and Clipper will choose the best option for your printer. If you really want to dig into it, it would be helpful, but for most, the auto will work just fine. Yeah, but I mean, I like to know how it works, right? I don't even understand how input shaper works. I mean, yes, of course, right now you can just click do your black magic stuff, and then now your printer has the black magic. But I wish I understand what's I wish I understand what's happening. Like what do they do? I don't even understand what's resonance in a printer, because I mean the head is always moving, and then I mean I just don't understand. I might be the only one, but I just don't understand frequencies. So I need to level my print bed with a tuning fork. Hey, Builders Mark, how are you? What's up, Everything Plus Ultra? Or is it because it's too complicated? Like there's no way we can understand? Yeah. So what he just said, we make the head move a specific path to induce the frequency of resonance. Is it okay? Okay, maybe there's something that is happening in my mind. Let me go to PPT time. PPT time for the new people. I always use PPT to try to understand what's happening because wait, so I need to yeah, that's the annoying part if I don't share my whole screen. So I need to do this, and then I need to do this, then I need to go back here and then share again. So let me see. Is it something like this? So when you ask, so let's say you have your tool head, and the tool head is okay, so it's not moving, right? So it's at resting position, and then you ask him to go somewhere, okay, and then you have a certain acceleration and top speed. Okay, that's the only thing, right? You ask him to go from point A to point B, right? And with a certain acceleration and top speed. So I guess what they are saying is, as soon as you ask him to move, and there will also be a jerk, right? And I think that's one of the most important, is because as soon as you ask him to move, he won't move like from 0.00001 millimeter per second, 0.0002, blah blah blah. I think the command will go straight to a certain speed, and that's the jerk. I think jerk is kind of initial speed. I mean, very simplified. It will straight go to a certain speed. It won't go like from a very, very small rod, because that would avoid any vibration. But the fact that you ask him to go, you have the first command. It's gonna make the stepper motor move suddenly, and I guess that starting point will make the system start to vibrate, right? I guess that's what he's talking about. And then he's looking for that frequency of resonance. So for a certain acceleration and a certain jerk, I guess even I'm pretty sure top speed has nothing to do with this. For a certain acceleration and a certain jerk, I mean, top speed is just important for how long it's going to last, right? The acceleration. But for a certain acceleration and a certain jerk, what's the frequency of resonance? Does that make sense? And you have to check that on the x-axis. So that would isolate the x-axis system. Then on the y-axis, that would isolate the y-axis system. And I don't know if they do some calculation to mix both, so they don't have to test both. And then for the core XY, then they have to do a 45-degree test and a minus 45-degree test. That's my guess. Or at least logically, it seems to make sense. Sorry. It is testing the vibration. It is detecting the axis, so it knows with calculations, what speed you can achieve and how it will tune out the echo. Yeah, so that's what we're trying to understand. What's this echo stuff? This explain it very well. Ringing, echoing, rippling, how to solve. Okay, how custom medic, computer medic, sorry. Computer medic. Let me open your link. Because how to solve, I mean, we all know how to solve, right? But we may not all know how, where is the, oh, here. This one. How to solve, okay. And then, okay, so let's have a look at this one. Let me move this to here. Let me move this to here. And then share it again here. Okay, let's have a look at this one. Okay, let me. I see some long explanation. Let me read that first before I read this. Kenneth sang, when the head changes direction, it vibrates and shakes. When it changes direction or stop, input shaper is something that you run on the Pi, which an ADXL sensor to measure the vibration. Okay, yeah, okay. Yeah. I think this part I got it. So every time the head is going to move with a certain acceleration and a certain jerk, it's going to create vibration. And the first step is to calculate all of this vibration. Okay. So this one, okay. This one I got it. Now the question is, we'll check later, but how many acceleration and how many jerk do they test? Do they test everything like acceleration, or do they test like 10 millimeters per second square, 20 millimeters per second square, 30 millimeters per second square with different jerk? Or how do they test everything or something like this? But I guess we'll check that. I feel like vibration wouldn't be a cause. Everything is damped and thawed, and with the adhesion, the whole printer would have to move in an extreme manner to cause a layer issue. I don't get it either, unless the filament itself is vibrating during extrusion. Silverback, like we said before, the issue is not vibration nor resonance. The issue is the printer is deforming. So that's the issue. The issue is you're going to flex the printer. Whatever vibration or resonance, if the printer doesn't flex or doesn't deform, it's not going to create any issue. So the problem is that, the printer is going to deform. The motors are transferring vibration to the head as well, yeah? Well, let me think. Is it? Let me think. What's actually creating the vibration? So you have the motor, and then it will suddenly spin, and then the belt will suddenly move. And I think the real issue is, okay, here's how I see it. I don't think the motor has much vibration, to be honest. I think it's fine. If you just have a stepper motor, and then you have the thing here that is suddenly spinning, I don't think it will induce a lot of vibration. What I think is happening is the thingy, the gear is suddenly going to turn, right? And then it's going to make the belt suddenly move. But the belt is flexible. So I think the belt will start to move here, but will still not move at the hot end, right? And then the force is going to arrive to the hot end. And what I think is happening is that it's going to suddenly push the hot end, but it's going to push it a little bit too much than what we ask, just because of this accumulation. And then, so what's going to happen is it will come back, and then it will be pushed back, and then come back, then push back. And that's what's going to happen when you suddenly ask the bed to move. So you suddenly ask the bed, so it's like this. You have the belt that is going to ask to move, then it's going to move too much, and then it will retain it, and then push, retain, push, retain, and then it will vibrate. That's what I think is happening. You're good now with presentation. PPT Excel, that's my skill. Certain components have resonant frequency that will do the same. Yeah, and I think we're talking about, it's not the resonance frequency of the belt or the motor or blah blah. It's the resonant frequency of that system, of the fact that you have this that moves, and then it's going to do ding, 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 like this. So that's why I'm saying when input shaper need to test, they need to isolate the x-axis, isolate the y-axis. But in the core XY, they need to isolate each system. So in the core XY, you have to isolate the basically what's moving. So in the core XY, if you go on a 45 degree, you only have one system that is moving. The other one is kind of passively moving, but I think you test that, and then you move on the -45, and then you test the other part that is moving. And I guess that's, I think, at least it start to make sense in my mind on how Input Shaper is working. I mean, not working, but at least the root cause of everything. It might completely be out of the how it actually works, but at least it start to make sense in my mind. Then using the chart provide you can see which canceling also MZV or 2H or whatever, and a value to slow down or change, adjust the speed so it don't vibrate as much. Jerk is the ramping power of a requested speed. Jerk is a ramping power of a request. That's acceleration, no? I thought acceleration is how fast you are going to reach that speed. Jerk is what's the instantaneous speed that you're going to ask for. Or at least that's how I understand it. You have to check on X, Y, Z. Don't really matter. I think it does matter, Kenneth Tseng. I don't think there is a. I think each system has a resonance of frequency, and I think they are different. So I would say it matters, but I don't know. Computer medic. Your extruder, metal part, fans, and all sorts can get heavy, and coupled with the fast movement result in something called movement inertia. Different combination of movement speed and directional change with the weight and your printer component can result loose movements. When there are quick directional changes with your printer, this movement can cause bend and flex in the frame. If intense enough, the vibration are likely to leave you with imperfection on your print. Yes, computer medic, that's very well summarized. And yeah, I agree. The echo is the ringing you get in prints from holes, text and features when you get going fast. Yeah. There's also the inertia at the start of the acceleration that you have to count. And when you reach the end of the race, you have to think that it stops suddenly and it gives a blow, which can still cause vibration that are transmitted to the gantry. It would take a kind of pendulum, like there's super high building, which with the swing compensate for the attack of the. Yes, yeah, 100% agree. 100% agree. It's tested in frequency, tests up to 133. Oh, it's tested in frequency, so that they test different frequency. It's good to keep your sense of humor during transition. Kenneth saying, yes, it tries multiple different speed, frequency, and it does a Fourier transform to try use all 4 or 5 algorithm to cancel the resonant frequency. Oh, okay. Start to make sense more and more. I'm going to take a video of doing it okay, yes. Yeah, that would be useful. The momentum of starting and stopping causes the vibration, yeah. Running Input Shaper will slowly increase the speed acceleration from 0 and measure the vibration bending by frequency measure in hertz. By knowing the resonant frequency of each speed acceleration, the firmware can compensate for it. Yeah, okay. I start to understand. This is why I'm just repeating so much. The science always evolving. Yeah, I also enjoy so much. Hey, Corcon, how are you? So would jerk be the measurement of 0.1? Sorry, Silverback, I don't understand. Jerk is acceleration, just to make sure we have the same definition of jerk and acceleration. So for me, is this. So if we have to draw the speed, let's say the speed chart, right? So we do our speed chart. So this is the distance. Okay, this is the distance, and this is the speed. Okay, and so distance, let's say position. Okay, so you have different position, and then here you have A, B, C. Okay, A, B, C. Okay, and what you are actually doing, so the printer path the printer path is going to be something like this. Go from A to B, and then from B to C with a 90-degree angle. Okay, so just to make sure we have the same definition, right? Once again, so for me, at point A, so let's put A here. Let's put B. Let's put B. Let's put B here, and let's put C here. Okay. So for me, the speed is going to go this way. This way, and then this. Maybe so something like this, and then it will go down to B, and then go up. Let me know if you agree with that, but that's for me what the speed is doing. And then let's say C is the end of our print, right? Okay, and then how I define everything? I define the speed, printing speed. So I like to say top speed, but is this level? Okay, this is my my top speed, like 100 millimeter per second. Okay, that's here, and that's defined by my speed, and then like slicer speed or whatever, and then acceleration. Okay, for me is the angle here. Okay, so the angle here is the acceleration, and for me jerk is the distance here, because the printer will allow the print head to not reach a full stop. So this jerk will it's calculated, right? But basically you can even I would even say you can start. So theoretically, if you do the calculation, you have well, let's say something like this. So for me, jerk is this. Is the instantaneous speed change that is allowed. Okay, so this is how I picture how speed change, just to make sure we have the same definition of acceleration, jerk, and speed. Jerk is the change in acceleration over time. Yeah, but I mean, that's the standard definition, right? It's the derivative of acceleration. But let's say if you want to visualize it a little bit, and I mean, yes, by definition, this jerk will indeed be the change in acceleration. It seems all the really high-speed 3D printer use Core XY, where the print does not move except down slowly. Yeah. Think of it like drag racing from load at a dead stop to the movement the vehicle moved, and measuring the time it took to go from 0. Now I'm on the same page. Okay. So that's how I define speed, jerk, and acceleration, and hopefully that's the real definition, or at least how Slicer are seeing it as well. So, okay. So I guess that's it, right? So to summarize, okay. So what I want you to say is, depending, so the frequency of resonance, or how the printer will resonate, do we agree that it only depends on the maybe the acceleration, the jerk, and the direction? Do we agree that it only depends on this? I mean, wait. Taking in account that the printer is the same, right? So of course it will also depend on the weight of the printer and blah blah. But let's say we are only on one printer, and then the frequency of resonance of that printer will change depending on acceleration, jerk, and direction. Is there anything else that would affect that? Talking about one printer, like one system. Graphing over time is clearer than over position, in my opinion. Yeah, but I guess it should be the same, no? time or position. Yeah, I guess it should be the same. But yeah. So yeah, do we agree with that? These acceleration. So yeah, and why I put it direction is because depending on the direction you're going, then you might have the weight that it involves is different. So that will also affect the vibration. So only acceleration, jerk, and direction. Rigidity of the filament, heat for meshing layers, a tug. Rigidity of filament, do you think rigidity of the filament will... Theoretically, I think I understand what you mean, but can we consider that negligible? Will you really have a big change if you go from TPU to PLA? Or can we consider that is negligible? And sorry, Gis Vester, I don't understand. Heat for meshing layer a tug together. Heat for meshing layers together. I don't understand the second. The first one I understand. I think it should be negligible. The second one I don't understand. So yeah, we can consider rigidity of the filament as a factor that would affect. But I would say rigidity of the filament, but maybe negligible. Or do you guys have experience where it does negligible? Negligible. Okay. Or do you guys have experience where you really have some issue when it comes to different filament? It would depend if you have a moving bed and a really tall print. Oh, yeah, that's a good point. Oh, yeah, that's a good point. Yeah, but I guess, yeah, that's a good point. But I guess input shaper cannot do anything about that, right? Yeah. That's a very good point. For Bake Slinger, or not even for Bake Slinger, like for any, yeah, geometry, and I guess size, which is including in geometry of the print. Yeah, that's a very good point. But I guess that's the part that input shaper cannot do anything, right? Input shaper cannot test all the geometry, all the different sizes or something like this. So I guess it's another factor, but I guess cannot be tested. Well, more melting, so it hides the ringing. Oh, but I think you are talking about something else. You're already talking about you're talking about the ringing. We're talking about vibration. What factors would affect the vibration, will change the vibration? Then material may have an effect. Yes, okay, like yeah. Material, geometry. So the print. So basically the print. So what you're printing. Will affect. Yeah, I agree. Jiggle when water has wave. Jello jiggles when water have waves. Hey, wasting time. How are you? The tightness of the material bonds carry the wave. Okay. Okay, so no other things, factors or something like this. Acceleration, jerk, initial speed, and direction. And then Jay Svester talk about rigidity of the filament. So why I think it does make sense is because if you have a very rigid filament here, it might help with, it might create some force on the print head, or TPU might not. But I think is very negligible in a way that, especially if you have a reverse Bowden, or if you're using a Bowden printer, then I would say it wouldn't really matter. It's very negligible. But I think he was talking about after you print, how does it affect? How can it compensate the ringing? But we're more talking about the vibration here. Using a bed slinger as the print mass increase, it could change the Y acceleration and the flex of the print. Yeah, it could, but I think it's not only bed slinger. Even if you have a Core XY, for example, a regular Core XY with Ilchimaker style, even if you have a long one, then it would still affect, because the whole printer will be shaked, so it will affect how it will how it will vibrate, or how it will affect the print. So yeah, I would say it's not only bed slinger. It may be, yes, it may be more, it affects more for bed slinger, but it does affect a lot for Ultimaker style as well. Like I used to print a lot with the Ultimaker 2 Extended Plus, so it has a long Z, and when I print a high tall prints, then I also had that issue. No, it would be model dependent. Input shaper couldn't deal with it. Yeah, okay. So we agree with that, right? Wasting time. I'm doing very, very well. I had a very restful holiday, and I'm ready to start 2023. Very motivated, very rested, and full of ambition. From frame flexing, it is transferred to actual print. From frame flexing, it is transferred to actual. Yeah, this I agree. Svester, I agree with that. And that's the issue, right? The issue is that if your printer is gonna flex, then it's gonna transfer that to your print. Okay, so if we have this acceleration, jerk, and direction, then and you guys were talking about input shaper is actually testing different frequency. So do you mean, I'm trying to understand why input shaper would, so what you're saying is it would take the print head, putting in the middle of your printer, and then it would make it vibrate at different frequency, right, on the x-axis. So why would it do that? So we are on both direction, right? On the direction from top down, we know that input shaper is solving this, blah, 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 and we know that it's testing by putting the hot end in the middle and then just making the whole thing vibrating. I saw some videos and it's just making this. So we know this is top down. Bottom up, we know that, so we did all of this analysis, and we know that what will affect the flexing of the printer, the vibration of the printer, is acceleration, the jerk, and the direction. So how do we put them together? Why is that going to test? We know the real testing is test different frequencies. So how do we go from why test different frequency? Why not testing different acceleration, jerk, and direction? And then you will have an overall understanding of how the printer reacts, how the printer vibrates depending on acceleration, jerk, and direction. Is it because frequency equal acceleration, jerk, and direction? Is that the reason? So you get what I mean? We're trying to link top-down and bottom-up thinking. Okay, so it's testing from 0 to 130 hertz. It all comes down to max speeds every printer can handle. Go beyond those max speed will introduce errors and cause print fails. DMAT, it comes down to the max speed every printer can handle. So how do we define what is the max speed that printer can handle? I mean, to be honest, if you think about it, any printer can reach light speed, right? I think it all comes down to acceleration and jerk. I think max speed doesn't really matter, no? Or yeah, it matters in a way that you can define the maximum jerk and the maximum acceleration, and then the longest path that the printer can make, like depending on how big the printer is, and then you can calculate the maximum speed. So yeah, in that way, I understand. But why I say light speed is because it can just slowly increase to that speed. But yeah, if you take in account that it's that is a limitation, there is some limitation, then yeah. And maybe you're talking about material limitation. Maybe the force required to go at a certain speed cannot be sustained by the belt, for example. But I don't think so. I think all the materials from the printer can handle very, very high speed. But I think the limitation comes from the jerk and the acceleration. Because acceleration will really put a huge amount of force on the belt. And I think that's the issue. And the jerk also. The jerk can literally break your belt. You can ask Zombie, by the way. I think he had that issue with his first testing on the Rook, if I remember well. I think his belt was always coming out. Svester, could we draw parallels between input shaper and mesh bed leveling, where the slicer builds the G-code with accommodation variables from its various tests? Whoa, what? Could we draw parallels between input shaper and mesh bed leveling, where the slicer builds the G-code with accommodation variables from its various tests? I think I get it. I hope I get it. But do you mean parallel between input shaper and mesh building? Where? So do you mean depending on where the head is, the input shaper will perform differently, or you use too many complicated words, Svester? But I think I get it. So actually, that's a good point. Actually, position of the head is also important. Yeah, Svester, I don't know if that's what you're talking about, but you just added a good point. Depending on where the hot end is, the resonance and the vibration will be different. So it's not only about in which direction is moving, the acceleration and jerk, it's also about where the head is. If the head is exactly in the middle of the printer, maybe it will vibrate more than if it was very close to one of the frame. Oh, that's a good point. Yeah, it's a very good point. Position is also important. So maybe is input shaper taking that into account, or consider it as negligible? Because when I see input shaper testing different frequencies, I think it's only in the middle. It's not going in a different like a mesh bed leveling. It's not going at different place and doing the vibration, which theoretically it should, because I guess depending on the position is different. Oh my god, I love that Printbusters. I really, really love it. I learned so much. There might be most of you that are like, finally he understands. But yeah, I'm slow, but I'm getting there. Hey, Zombie, you're back. You keep going up in speed till you get skipping. Yeah, there's also the force that the stepper motor can handle. Yeah. Max speed is counted as when in the test the little CC patterns don't merge together. Oh, sorry, I don't know what it is. It is very long rabbit hole you can travel down. Yeah. I love rabbit hole. The vibration input from the printer and the response measure with the accelerometer give the resonant frequency of the printer. Yeah, by avoiding these frequencies or some other clever changes in the movement speed and acceleration, etc., the printer can reduce ringing in the printer. Yeah, so I think in Senium you're already going to how input shaper is solving that problem, right? I'm one step behind you. I'm trying to understand. Like I said, top down, we know that it's testing different frequency in the middle of the printer. Bottom up, we know that we need to understand the acceleration, the jerk, the direction, and the position in order to define the frequency of resonance. So theoretically, from our reasoning, it needs to test all of this in order to know the frequency of resonance so that we can go to the next step, what to do with that frequency of resonance. No, the induced voltage in stepper motor limits its higher speed. Oh, let me think. Yeah, but that's the same, right? Voltage and maximum strength or power. Yeah. I agree, but I think it's similar because the voltage translate into the energy, right? So the maximum energy that it can do, right? So that also limit the acceleration, right? If the stepper motor is not powerful enough to get to handle the strength of the actually not only the voltage, because if you think about it, if you have the step, oh, we have zombie coming in. Let me add zombie. Can you hear me?
I can hear you. Hello.
Okay, awesome. Let me just finish my my explanation for NSCHO. So voltage is what I was about to say. Oh yeah. So voltage will define a maximum speed without any load, right? Because if you add load for the same amount of voltage, you will go slower, I assume. So I think it's a mix between both that will define the high speed. But yeah, that's a good point. How are you, Zombie? I'm trying to catching up with the chat slowly.
That's okay. So did you learn all about input shaper now?
I haven't connected top down and bottom up yet, but bottom up we arrived to. So we started by what actually create the ringing. So because
Okay.
people they talked about vibration, resonance, and
Yeah.
hi Ginger, how are you? Are you
Hello.
following? Are you following? So
All right, liking, subscribing.
and what was what to say? Yeah, and I was my explanation was more towards the printer deforming. So vibration and resonance is not the root cause. The root cause is that the printer is going to deform, the belt are going to deform, or the frame is going to deform. That's the actual issue. And what's
You think so?
making
Okay. All right. That's what you think?
Yeah, and what's making it deform is the vibration, and in particular the frequency of resonance, because frequency of resonance is defined, if I remember well, by a frequency that will naturally increase the amplitude, and amplitude means deformation, right? So first, the root cause is the printer is going to deform, that will create the artifact on your print. What's making it deform is the frequency of resonance, because it will gain in amplitude. Amplitude means the deformation, right? And what's creating this, how do you define this frequency of resonance is, well, depending on the materials you're using, etc., etc. And
Okay, yeah.
and the next and then the next step, we define a little bit more what were speed, jerk, acceleration, etc. And then we try to define all the factors that would influence the frequency of resonance, because I do not believe a printer only have one frequency of resonance. I think it depends on many factors, and we ended up by saying acceleration, depending on what acceleration, what jerk, what direction, and what position your printer is in. All of this will define a certain resonance of frequency. And then some people were talking about rigidity of the filament, but I think is negligible. And some people talked about depending on the geometry of the print, but this anyway cannot be tested. So we arrive at, okay, now we have to test acceleration, jerk, direction, and position. And from a top down, we know that when you do the input shaper test, it's putting the print head in the middle of your printer, and then it's testing different frequency from, I saw in the chat, from 0 to 133 hertz. So the question is now, what's the relationship between our, like how to connect our bottom up and top down? Like why it's testing different frequency? Is frequency the same as all of these? Or maybe finally they don't test position, they just put in the middle, they just think that wherever the printer is, whatever position the printer is in, it will be more or less the same or something like that. So anyway, I just catch you up on 2 hours, 1 hour and 20 minutes of stream.
That sounds about right. Okay. So I've been personally, diving into input shaper and resonance compensation almost since I started. That was the main reason, one of the main reasons for going with Clipper, is that it just allows you to do it. And I actually started with the manual measurement method. I don't know if you went over different methods yet. And also your camera is flickering. I don't know if that's
Yeah. Actually,
fixable.
can you let me know if is that
Yep,
is that
that's
good
it.
lighting if I do like this?
Yeah, that's fine. No difference. Actually, it's
Okay.
better with it off.
Okay. Yeah, wait off.
uh,
So you were saying, what were you saying?
so there's different, different methods of figuring out what, like the final step, like what frequency to actually choose for input shaper. You can use like the measurement method where you print something out and measure it, or you can use the actual ADXL and then find out. So I started off with the manual measurements, and that made such a significant impact on my print quality that it's hard to go back to Marlin without input shaper once you get everything tuned up. Like it's a significant difference.
Okay. So why? I guess that's I mean that's still the question. Like why would you test different frequency?
How would
Is
you
that
test
because
different
it's
frequency? Well,
because like I just said, like acceleration, jerk, and direction is the thing that's going to affect the frequency of resonance. So yeah,
it'll increase
Hmm.
in my understanding, all of those things will increase or decrease the amplitude of the resonance, but your moving mass is always going to be the same. So you're always going to get the same feedback, the same resonance. Doesn't matter what speed you go at, how much acceleration, it's always going to be the same. It's either going to be more or less. Right?
uh, so what you're saying is acceleration is not a factor that's going to influence the frequency of resonance.
It changes in acceleration. I would say no. It would just and acceleration and jerk is essentially the same concept. So
Let me think. Because let me think.
but there are some factors that I don't think are covered.
Actually, maybe it's going back a little bit, but
Mm.
why do we care about frequency of resonance? Actually, because any vibration will create issues on your print. Why do we focus on the frequency of resonance in particular? Because any vibration is bad, right? We
Well, it's not a vibration. It's the resistance and change in motion, which is going to be a very specific and it's going to be essentially looking for the most impacted or impactful thing, which is going to be resonance, because that's kind of what gets amplified throughout the printer.
Okay, so they consider that the rest is negligible, right?
Yeah, like for example, I can put my printer on squash balls, and the printer itself moves back and forth, but it's a relationship between everything. Maybe the printer's vibrating, but the whole entire printer is vibrating together, so it doesn't
Yeah,
matter.
I mean that was what we said at the beginning, right? The real issue is the printer flexing, not really the vibration. But
Yeah,
I
right.
guess
It's resistance. It can't flex.
hmm,
It's trying to stop, but it wants to keep moving, so that energy has to go somewhere, and it gets transferred into the print, and is defined with a chart. I don't know if you've shown that yet. An input shaper
no,
graph.
no, not yet, not yet. We're at the very beginning.
Okay, okay. Because that kind of
Um,
explains it all. If you jump to that, that'll really enforce or show like what you're talking about, or at least
yeah, but I
I
think
can.
it will skip the step here. It will skip the step of understanding the relationship between
Sure.
the acceleration, jerk, direction, blah blah blah, and frequencies. Because it goes directly to frequency. It talk about frequency, but we don't know why they talk about frequencies. Maybe you can try to answer my first question because nobody in the chat has answered that one.
Okay.
Is input shaper only useful to solve a ringing issue?
And that's what I was trying to think about. It's a good question, because what's the issue? Are you just canceling out the ringing? So, for example, I can look at this print, and I can see, well, yeah, some sections have clear ringing. Well, this one's actually not too bad. But in some prints, you see a lot of ringing, ghosting, and then it goes away.
Yeah.
Yeah, okay, I can see it right here. But the question is, when you cancel out those frequencies, does it actually allow you to go faster with faster accelerations? I think so. I think so.
Does it allow you to go faster? Because if you wouldn't have that, the printer would physically not be able to go faster.
You're assisting in it stopping, right? It's like it's a fancy braking mechanism. That's what it is. So if you can brake quicker, then I'm assuming you should be able to brake from a faster speed. So you can technically have faster accelerations and go faster. In theory, that's not something that I've tested or really thought about. But
Okay. So
yeah, that's what I'm. Maybe it's minimal. It might be minimal, but theoretically, you should be able to go faster, if not the same speed, the same maximum speed, but actual usable results. Because I
yeah.
think
So
your acceleration is going to be mostly dependent on your stepper motor, how much power that has, and I don't think that resonance compensation is going to impact a ton on increasing, its maximum.
yeah. Okay. We slow down in order to prevent ringing by compensating for the resonance. We can increase our speeds before it starts ringing again. It doesn't change the physical capability of the machine, but it allows us to get better result at faster speed. Okay, so
Right.
the answer is yes, right? It's only useful for ringing. So if you're able to solve ringing by just putting a foam, for example, then you don't have to go through that. I don't know
Right.
how hard it's to do. I guess it's pretty automatic, so it doesn't matter. But there is
Yeah.
other solution to do that instead of doing all of this math, right?
Right. The best thing you should do is hardware, fixing it, making it better in the hardware aspect. So having a more rigid frame, tighter belts, etc.
Mm-hmm.
Anything that would decrease the
Yeah,
resonance.
but foam and input shaping will be better. Yeah, I guess.
Yes. Yeah. Input shaping is always going to give better results. Now, it does smooth. It does smooth out your print. So a sharp corner is now slightly smoothed. It's not as sharp as a side effect.
Oh, really? But
Yes.
okay, so this part might be later on in the
Hmm.
understanding. Then I really don't
But
understand
we
fully
can
what
we can get
changing.
into the bamboo and how it's actually too aggressive compared to other printers to get to those speeds.
Oh, okay. This part I really don't
Hmm.
understand. So maybe it's even changing the path in order to solve the problem. So so it's rounding out, because if the corner is rounded, it means the path has changed, right? So it's affecting the path, which I had no idea. It's a good learning. I thought
I
it was,
so, it's I don't know much about it, but yes, it will definitely take. If you do like zigzags, it'll take them. It'll smooth out the corners.
wow, okay. Oh, that's
Hmm.
very interesting.
Hmm.
I didn't know that. So let me record that, by the way, because I don't
And
think
then
we're gonna.
more aggressive algorithms for input shaping will cause more and more smoothing
Oh,
at faster accelerations.
so maybe that's okay. That's maybe how it's solving it, because jerk will be much higher if the directional change is high, right? If you have a high angle, then the jerk will be higher. So maybe it's solving that by dividing that angle into a lot of small angle, so that the jerk will stay within a certain limit, so that, let's say, at a certain jerk, it reaches a too high frequency, or I don't know, but it makes
Mhm.
the printer deform too much. Then it's going to break down that angle into many small angle, so that yeah, I mean, it makes sense, but I didn't know it was solving problem in this way. But that's going to be
Right. So
nice.
there's a very big downside in very fast accelerations.
Yeah. Okay. Will it change the dimension slightly? Well, theoretically, yes. If it changed the path, then it would change slightly. But I don't know to which extent. Maybe it's negligible. I have no idea. Ask Zombie what's up with thermal runaway this week. What do you mean? You mean the bamboo stuff?
There's a whole
Oh,
discussion on our Discord if you want to read into that.
oh,
But
okay.
TLDR, they just kind of guessed for the thermal runaway. It's like 3 minutes should be fine. And then the community's like, that's not the standard. You should do something different. That's
By
all.
the way, I did some research on the material side.
Yeah.
A lot of people are talking about the auto ignition temperature.
Yeah. What's up with that?
So I did some research. I'm not an expert in that, but from what I heard, from what I read on the papers, what will auto ignite? So you have first it will reach pyrolysis temperature, right? Pyrolysis temperature means you will start to have reactions within the materials, and then the product of that reaction is carbons and then some gas and some flammable gas. And then that
Okay.
gas, if that gas reach the octo-ignition temperature, 360 something, then it will auto-ignite. And then depending on the exothermic reaction that it will create, if it compensates the endothermic reaction of the pyrolysis, then you will have continuous flame. So I think anyway, the point is the gas needs to reach the auto-ignition temperature, not the solid material. The solid material doesn't matter. The solid material will never catch fire. It's the gas
Right.
that catches fire.
Okay.
So I think maybe what people forget is maybe the solid material will reach 380 whatever, but maybe the gas will escape directly. Maybe the gas will never reach that auto ignition temperature. Maybe, I don't know.
What you're saying, there's a chance.
Not a chance. If what I understood from
Mhm.
the chemical reaction, what is happening, if that's really happening like this, then oh yeah, I understand what you mean. So yeah, I don't know if that gas is actually reaching, but to make a gas reaching that temperature, knowing that it's expanding in a nozzle that is completely open on the top and at the bottom, I think it's very hard. But I don't know.
Yeah.
I don't know.
No, and if anyone's worried about that, like as the bamboo specifically being a fire hazard, it's enclosed. I don't know. It's really tough to say. Hey, Zolan, thank you for rating with the party of 5. What were you streaming today?
So much more reactive than me.
Right.
I saw it like seconds after you. They were too. No bamboo head here. I know there is some stories around Bamboo Lab, which apparently their community is not that friendly or something like this. By the way, I don't believe in a non-friendly community. I believe in people that may have answered non-friendly answers, but putting
Right.
the whole community in the same bucket.
Right.
That's a lot.
I joined their Discord, and I poked around, and there may be some loud people on there, but in general, I would say it's no different than any other Discord I've been on. The Voron community has had the same issue because it's so large. You have some people saying kind of extreme things. So in that sense, Bamboo, Voron, it's kind of, it's just people. The communities are okay.
I didn't know Zolan was playing piano.
Oh yeah, still practicing piano. Awesome.
Nice.
I have a keyboard I have to make some music with eventually.
You have to teach Zombie. I think he has a synchronizer, or how do you call it? Synchronizer.
Yeah.
Synthesizer.
The synth, yeah.
Yeah. So, by the way, I'm hoping to have Bamboo on stream to have all of this open debate. There is no, whatever is said on Twitter. There is nothing between Polymaker and Bamboo or whatever. It's some very friendly discussion on how we can bring our industry forward. So we'll be able to talk about that. With Voron, people get tired of the noobs asking the same question over and over, and the repetition gets annoying. Yeah, but that's the part I don't want on the Polymaker server, and I hope because
you should always be friendly to anyone and answer their question. Or if it is a repetitive question, if there's a solution, just link them to there. Say, hey, check this out first. Maybe come back if you have more questions, especially if it's
yeah,
a long discussion.
if an answer is simple, then just answer it. If it's really simple for you and you think it's very newbie, then answer it directly. If you think you don't have time to spend answering this question, then don't answer. But if you spend time to purposely say, why you don't do your own research and blah blah, it's very easy. Then just spend the same amount of time just answering the question.
That's the thing, right? You don't have to say anything. You don't have to answer. No one is asking you directly, and you're not obligated to give an answer. I would rather people not answer a dumb question at all than to say, "Oh, your question's dumb." Like, just don't do that. Don't do that.
I did receive a couple of feedback. Like, I'm not talking about 2 or 3, but a couple of feedback that our Discord was very friendly for that particular reason. They came to me and they say, I really appreciate that you guys spend the time, even I'm a newbie, blah blah. So it's I hope we can continue in that direction, because I know it's gonna happen at some point. But we have, that's why we have moderators. That's why we have all of you guys that are helping to bring the community in the right direction.
Yeah, of course.
I need an 88 keyboards controller so I can learn a song I found, but until I'm better, I was with 49. 88? How long is an 88 keyboard? How many
like a full size
on yours?
Mine? Oh, I have a little MIDI. It's
Like
nothing crazy.
No.
Actually, I don't even know. It's not huge.
Okay.
It's mostly for just having a digital or an analog way of saying. It's 25.
Well, it's close.
Something like
that. But okay.
But it's a lot easier to play the piano on the piano than it is to do it in software. So
unless someone tags you individually or send you a direct message, I mean the same. If you receive a that you don't want to answer, then just don't answer. I just don't understand people spending time saying things like, it's a dumb question or do your own research.
Yeah, right.
At all, or
I see that in every server. It's kind of not upsetting, but it's just kind of sad that people go out of their way to make people feel like they don't belong or they're not involved, because no one's going to learn that way.
Admittedly, I've came across harshly to people who are asking questions they shouldn't be asking, specifically around mains power. I really don't want to see someone hurt because they don't know what they're doing. Semi HV stuff. Yeah, I mean, sometimes, I can understand that sometimes we can get emotional about something. Like, it can happen to me that, someone is asking something very bad or something like this, and then I may have answered something that I may regret after. But this I understand, right? But if you go to some Facebook group, it's like consistent and usually similar names. And it's like they spend their time doing this. So it's, I don't know.
Yeah. Anyway.
I know have great knowledge. So is it better to have cardboard reels or have people send back the plastic reels? Why? Okay, so you arrive here, you drop your question, right? Is it better to have cardboard reels or have people send back the plastic reel? Definitely cardboard at the moment.
Shipping is a nightmare for the environment. If you're talking about, it'll easily negate any benefits you get from recycling the spool.
There's maybe that part. I don't have actual numbers on carbon footprint of logistic or something like this, various plastic. But what I can tell you is that nobody in the world is going to pay $3 to $4. Is going to pay $3 to $4 to send back a plastic spool. When you say have people send back, most of the people, I don't know if you are thinking this, but you are thinking about us paying for that. But of course we will not either, because it won't make sense for our business. So as long as we don't have a supply chain that economically viable, right? A supply chain that is economically viable of taking back all of these spools, then we won't be able to do that.
Right.
So that's the reason why I think cardboard is the reason. I mean, can you imagine sending all of these plastic spool back to here, China, and then we wind again, then we send it back to you again?
Yeah,
So,
that doesn't make any sense.
but it could make sense if, for example, I don't know, you have a local supplier, and then you're dropping by before going to work, and you drop by your spools or something like this. Or I'm not saying
it
makes sense. I'm just
what's
saying
what's that program from Earth? So you bring your spools to this person at
yeah.
Earth, and then they take it. What's up with that?
I think it is which brand it no, not IC3D.
No.
Oh, I don't remember. Yeah. I don't
Someone in chat
remember.
would know,
But yeah. I must have missed a lot. Was desperately cleaning the office.
Green Gate 3D. Okay.
Oh, Green Gate 3D? Yeah. I think it was this one. Nix, stay out of ham radio group. They are the worst for that. Sorry, I don't know what's a ham radio group.
Just like amateur radio. I'm actually I think I'm still licensed.
Okay.
We did that in college.
On Facebook, you have to be happy if you get them for blah, blah, blah. PMSRV, Polymaker Spool Redemption Value. Yeah, I mean, I'm open to ideas that would make sense, right? If you have an idea that would economically and business-wise make sense, then of course we are always looking for being more sustainable. I mean, when you think about it, even the carbo spool, I mean, they are not bad, right? Sometimes after you finish the carbo spool, they could be reused. That's how good they are, in my opinion. Some other, after you finish them, they won't sustain another winding. Spoolless for the win, yeah. IC3D also had a spool take back reuse program and will collect spools at event. Yeah, I mean, Green Gate 3D, IC3D, they are all US based, if I remember well.
Yeah.
So it might make more sense for US based. I mean, even I don't know how they do that or who is paying for that, but
that makes sense though. It does. If you have a plastic spool and you're in the US and you take them back, and it's done in a way that's economically and environmentally viable, then sure.
Yes.
Okay. The tangent.
Yeah. Just to rest our brain a little bit, but let's at least try to finish. Try to understand the test itself, and then in the next Printbusters we'll see what Input Shaper is actually doing, how it's modifying your printer or G-code or whatever it's modifying. But let's at least try to understand the test, like why it's doing that, why it's putting the hot end in the middle of the printer and shaking it. So that's what I want to understand properly. So we, I think Numeric said something, but I cannot go back now. But said something interesting about. No, it was not this. Yeah, sorry, I skipped some of the chat at the beginning of our discussion, and there is something interesting from someone, but I don't have it here. So, yeah, guys, try to help me understand why Input Shaper is putting that head in the middle and shaking it compared to what we just said, like acceleration, jerk, and direction. So, of course, Zombie said that maybe acceleration has not much to do on how it will affect the result, but definitely, so position we can remove because maybe you can confirm, Zombie, when it does.
So position,
like when it does the test, is it putting the hot hand here and then vibrating, then here, then vibrating?
You can put it wherever you want, but what you typically do is you put it where you print, right? And you're going to print in the middle of the bed, so you're kind of simulating in the middle.
Okay. So position is not there. And then direction, is it vibrating like this, and then it's going vibrating like this, and then vibrating like this, or it's only vibrating in one direction?
So it does each axis at a time. So do the x-axis and then the y-axis. On a bed slinger, it'll do the tool head, and then it'll do the bed.
Right.
But on a Core XY, it'll do one direction, then both direction,
Yeah.
but not diagonal. No,
Oh,
it does
not
it in the X and then the Y. So it'll use both motors.
Okay. So that's good. So direction is, as we analyze it, is an effect. Okay.
Yeah.
Now the question is the different frequency. I guess the different frequency is the different acceleration on jerk. Like, let me think. Because um, if you go at 1 hertz, then 1 hertz means it's going to move. If we amplify, it's going to move very slowly. So the acceleration and jerk will be very slow, right? And then if you go 133 hertz, which means 133. Yeah, what's hertz actually? Is that the cycling? So
Yeah. It's
133.
how fast it's cycling.
Yeah, so 133 is 130 cycle per second. So that because
Yes.
hertz is a particular movement per a particular cycle per second, right? So that's the
Right.
definition of hertz. So 133, does that mean 133 back and forth in 1 second? So one
It's
hertz,
it's it's
ding, ding.
creating a frequency that you set. So it's creating a frequency by vibrating it.
Yeah, but what's the frequency? Because frequency means something is cycling at that certain frequency. So what is cycling? Is it the hot end that is doing 133 back and
I'm
forth? Like
assuming so. Yes.
hertz is cycle per second. Yeah. And Chewy, yes. Okay. So it is the hot end. So we're talking about the frequency of the hot end, of the movement of the hot end. Okay, got it.
Yeah.
Hertz correct per second. Yeah. Hertz is 1 second. So means it moved 130 back and forth. Okay, got it. So go from 0, doesn't move, 1, go back and forth. Okay, so it's basically, so frequency, testing different frequencies is basically testing different acceleration and jerk. Like if you want to do 133 movement per second, you need to have your acceleration on jerk very high, right? I mean, what's the amplitude? Do you guys know the amplitude of that movement? Are we talking about 1 millimeter? Are we talking about 1 centimeter?
It's not very much. Just kind of wiggles it. It kind of shakes it. It doesn't really move.
I mean, shaking is moving, right?
Well,
What's the
yes.
it must have an amplitude, right? The G code must have an amplitude. It must be like if you look at the G code, it should be go from A to B at this acceleration, then go from B to A at this acceleration, then go from B to B. It must have some.
It's probably around like 1 millimeter. It's not very much. It kind of like at high frequency, it doesn't look like it's moving at all. So
Okay.
can't be very much.
Is there a G code for that, or it's like it's embedded? I mean, there is no, because it has to send a G code anyway, right?
Yeah,
It's
it's
not
doing its own thing. In Clipper, it's running Python code and doing whatever it does, and that's all behind the scene.
Okay. Because I'm wondering if the frequency is not really the frequency of the hot end, but it's somehow related to the frequency of the current that is sent to the stepper motor or something like this. You know, like is that related to the electricity thing on the stepper motor? So that's
What do you
why
mean
I'm
by that?
asking. Like I know there is so. Well, actually, I don't know, but I guess the electricity has a certain frequency, right? When it arrives to the stepper motor, like it's going in one direction or the other direction, right? So if you want, for example, if it's positive, then it will go in one direction. If it's negative, then it go in the different direction. So if you send a wave that has a certain frequency, then it will go in both direction at a certain frequency. Does
Yeah.
term of electricity thing, does that make sense? Or
Yeah, I'm guessing it's the speed at which it receives, the speed at which it goes back and forth. So I don't think I'm trying to think, does the acceleration actually change? Or is it just accelerating as fast as it can? Because I think that's what's happening. You're going from one position of the motor to another position, back and forth.
amplitude tied to how big the E steps are.
Yeah, acceleration's constant.
There are also harmonics. So if you move at a multiple or a fraction of 133, it can also excite 133. Yeah.
Because the way the motors work is that they use individual coils, and these ones there's two of them. And I haven't really ever studied motors too much, just transformers. So you have your one set of essentially magnets, and then it jumps to the next set when you energize it. So you're like jumping between steps, right? So I think this is just jumping back and forth between two different steps, two different positions, at a frequency that's defined by 1 to 133. And then you're measuring the amplitude of the resulting vibrations.
Because okay.
Maybe help if I showed a graph.
Okay.
Let's see.
Pulse width modulation for X number of step on motor. The amount of resistance is the wire. It is the value you achieve from speed tests. The stepper motor have a movement limit, so the G code sets the number of steps on each axis. The better the stepper motor, the smoother and faster the print movement. Best explanation of input shaping I have ever seen on YouTube. Okay, let's check. Because I've received a couple of links, but it's too long.
Yeah. All right, I get some graphs up I can share after.
Yeah. Where's my... Oh, here.
Oh, this is the person that did the one of those tests. I think the rippling tests, I think.
7 minutes. 7 minutes. Okay,
Is
let's
this
see.
1 month ago?
Can you hear?
Duet. I can't hear now.
Oh, so I need to do... Yeah, I don't know. Sometimes...
Are we having a physics lesson? Well, essentially, trying to study it from as high level as we can without diving too much into it. Because I don't think either of us really know the physics, but we're trying to apply the physics into real life.
3DQ, how are you? That's Steven?
Brett versus Clipper.
That's Steven.
Yeah.
3DQ. We're talking about input shaper today. Or at least we're trying. We're trying our best to talk about.
Okay, your title. You ever change your title? Just says Printbusters.
Oh yeah.
What's up?
Yeah. Then I can talk about anything without. Okay, so you should be able to hear now.
The last section would be.
Okay. Okay, so let's see how this gentleman explained input shaping.
Unbox some filament.
Oh, Duet 3D. Okay, Duet 3D.
So basically, the last section would be deceleration.
That's right.
Oh, actually, let's go a little bit back in time before he started drawing.
Compensating for a mass ratio of 9:1 because the resonance frequency goes.
Are you sure he started at 7? Toronto Dan 3D? Looks like
Maybe.
He started earlier, no? Or he stopped
They're
at
probably
7.
explaining what input shaping is.
There was something wrong because if you have, say, a core XY system with basically the same belt controlling X and Y, to get a 3:1 variation in frequencies on X and Y axes, you need a 9:1 variation of the mass. You can draw graphs of resonance.
Okay, input shaping visually explained.
On the paper.
So you can draw graphs of resonance against frequency. So that's frequency. And this is resonance reduction, where that is 1, which means no resonance reduction at all. So without input shaping, you've got that. With our original dynamic acceleration adjustment, we had a resonance reduction that was V-shaped. So at 1 frequency, you have perfect reduction, but frequencies around, it is not so good.
Yeah.
So this is usually called, in fact, that's just Z input shaping. or in fact, it's ZV. But you can then have better input shaping algorithms which use more acceleration segments. And the next one, for example, you can do looks like that. It's called ZVD, where the compensation of frequencies around the center is better.
Yeah, so you have a little more wiggle room.
That's right. And then you can go beyond that. Is even worse. But there are other algorithms as well. And this looks something like
Steps.
without the compensation, you would simply have a steady segment, then one deceleration segment, then one acceleration segment, and then steady. So this is acceleration, that's deceleration, and this is constant velocity. So that's without input shaping. Because this is a sudden change, then very likely this deceleration causes a wiggle like that.
Yeah,
and that's when
so
you
that's-
get ringing.
That's what we want to get rid of.
That's what we want
That's
to
the
get
whole
rid
point
of.
all this.
So that's why we split the deceleration into a number of segments, and then we split the acceleration into a number of segments as well. And typically, these segments are all the same. They're usually half the frequency, half the period of the center frequency you're trying to compensate. But for MZV, it's a bit different. Now, if you use the same input shaping on X and Y, then everything's fine because the segments on X and Y are exactly the same. But suppose you don't. Suppose you're using very different input shaping, then you may have your steady speed segment, and here we need to shape X. So we change the speed, and then here we change X again, and here we might change it again.
Yeah, I don't understand anything. I will try to watch this
So I think the best TLDR is you're applying a negative pulse to what the measured resonance is. So each one of those segments is doing something to cancel out the frequency.
Okay.
So if it's moving in this direction and it's going to start making a vibration going like this, well, input shaping would try to make a vibration going the other direction. So it'd send it would modify the G code to send a pulse. So it's actually going to vibrate the motor with a controlled, with a controlled pulse to kind of emulate what it's going to do, which is why you have to measure it. So it's going to, instead of having a vibration that goes like this, right, the input shaper will cancel it out. It'll apply the opposite. So your G code's going to look like this, but in reality, it's going to make it so there's no vibration or minimal.
Yeah. But it's not a chord vibrates on as one frequency. Yes.
And then I can show you.
Let
me show you the graph.
Yeah. I think you should be able to share.
Yeah, I can just I have OBS, so.
Looks like 2 hours is my brain limit for Printbusters.
So I gotta add a window capture. Let's do
like this. Did you ever see Hunt for Red October? The silence sub concept is similar to this. Oh, sorry, I don't know what is this. If you think of water, the deep and valley are the frequency. Yeah, I mean, frequency stuff, I think I kind of get it, right? You have a certain frequency, and if you don't want that frequency, then you put an opposite. If you have a graph with a certain amplitude and a certain frequency, then if you don't want to cancel that out, then you put another one with the same frequency with opposite amplitude, and then that will cancel everything out. So this part I understand. What I don't understand is,
like what it's actually doing. Yeah,
what you guys are doing is still top down, right? But I'm still on the bottom up, and we are trying to merge. For me, I'm still at that acceleration and jerk and direction are affecting the vibration of the printer. And then there is this frequency that I'm trying to link. Well, why are we talking about frequencies?
And
okay,
I don't.
Yeah.
I don't know the specific algorithms and like what each one of these does, but this is what's in Clipper, and each one of these, so there's ZV, MZV, EI, and then the different humps of EI. Those are each shaping algorithms. So it's kind of dumb, right? It's a dumb system. It's a set algorithm that you apply one variable to, and with that, it tries to counteract at that variable. That's probably confusing things.
But like, for example, what? So the x-axis is frequency. Okay, no problem. So
yeah, so this is frequency.
That's from 0 to 133. Okay, so I guess that's why some of the curve stop at 133. And okay, so frequency. And then on the left y-axis, you have power spectral density. So
AKA, this is the resonance. So how strong the resonance is. So these bold, if you look at like the purple is all axes combined, aka what you're trying to compensate for. And you can see that on my test at this specific frequency, which is like 60 something hertz, the recorded power, not power, but the frequency that records, the amplitude is very high, meaning that this is a resonance frequency of the printer, whichever axis. So that's when it's going to have the most vibrations, is at this frequency. Does that make sense?
Yeah,
Probably not explain that well.
PSD. PSD is the measure of signal's power content versus frequency. The amplitude of the PSD is normalized by the spectral resolution employed to digital the signal. For vibration data, the PSD has amplitude unit of G2 per hertz. Okay, so it's kind of it's an index to show the amplitude, which means the amount of movement that this vibration is creating. Is that kind of what PSD is translating into?
It's how strong the resonance is, or how strong the vibration in the frame is. So if if I'm vibrating at, let's say I'm vibrating the tool head at 100 hertz, and it's not really creating much of a vibration on the frame, well, then the amplitude is low. But if it's vibrating at 60 hertz, and you can see the frame really vibrating, it's resonating, kind of like tuning forks, or, like a guitar, you have a string that resonates at a certain frequency. That's the whole same concept, is you're finding what frequency the system is resonating at. Or how strong of a feedback you're getting at each frequency. To make things even more complicated, let's look at any bad examples.
Okay, so is that because frequency of resonance is the part I'm a little bit more familiar. So I understand that each system has a natural resonance frequency, and then to find it, you need to test different frequency. And I guess the way you find the resonance of frequency is at which frequency the amplitude will naturally increase.
Yes.
Okay, so the other frequency, if you give him a certain amplitude, he will stay that amplitude. But at the resonance frequency, you give an amplitude and it will just increase and out of control. So does the PSD kind of measure how the amplitude evolve compared to the one you give? So it's kind of this, right? So the graph is basically spiking at the frequency of resonance of your system, right?
Correct. And it can have multiple points. So this is a very bad test. It's a bad result. There's a lot of issues with this test. So this was tested on a very, very, very loose hot end or something. So it spikes, it goes up here, it spikes at this frequency, also this frequency, and also at this frequency. So this is kind of defining what the printer is doing when it's experiencing a vibration.
There is a couple of people that would like to jump in to give some explanation. So you can DM me on Discord. I can invite you, and you can give your explanation if you don't want to write everything. Third dimensional print and Phoenix Call. Are you the two that want you to come in? If you want to come in, then discord.printbusters.com or what's my Discord already? Or whisper me. You can just whisper me.
Yeah.
You're on Twitch.
But you at least understand. You at least understand what's going on here, right? Like what the measurement is.
Yeah, here I understand. So what I don't understand is the different colors of the solid line. What are the different colors?
Okay.
Is that different direction?
Different axes. It's an accelerometer, so it measures in X, Y, Z, and the purple is just a combination of all of those. That's irrelevant. Well, not relevant, but it's not relevant for this test. It depends what angle you have the accelerometer at. You're just looking for the total amplitude of all axes in the one test. So we're just looking at the purple line here. I can go back to this other one. So we're just looking at this purple line, and in my case, my x-axis on the accelerometer was aligned with the x-axis, so it's essentially the same thing. You can see that here. So I aligned my accelerometer just about right, but maybe it's slightly tilted in another direction, so there's some resonance at a different frequency.
Oh, okay. So what you're saying is it has done one movement, and the accelerometer has broken it down to X, Y, Z, and whatever the T.
It measures X, Y, Z. It's an accelerometer, so it has three. Well,
yeah, X, Y, Z.
One of these has three axes.
So most likely here you have, I guess you have tested the x-axis, right?
It measures all. Yes, this is the x-axis on the printer, but it's recording on the accelerometer the X, Y, and Z coordinates.
No, I mean, I understand that, but the graph, can I assume that this graph is when you tested, when you made the frequency change from 0 to 133 on the x-axis? You were testing
on the tool head, yes. Yeah, so this is what this X is right here. So this is the
X. Okay, so that's the reason why the X component is the highest one. So if you do that on Y, most likely the Y component.
Well, no. This is just the accelerometer. This is purely dependent which direction the accelerometer is facing. It's a physical device, right? So you can orient it in any direction.
Oh.
Here, let me just switch back.
So what you're saying is it's not exactly the X of the accelerometer is not exactly the X of the printer. So that's why there's other component. Oh, okay.
Correct. You can have it in one way, and then maybe this is actually, it says Z. So you can ignore, for the most part, the X, Y, Z, and you're just looking at the combined output. Because if you tilt the accelerometer, it should still have the same combined output. 3DQ says the vibration frequency is depending on the change in velocity and in acceleration. The vibration frequency is the change in velocity and acceleration.
Where did you see that? Oh, the vibration frequency is depending on the change in velocity and the acceleration. But change in velocity is the acceleration, right? Or do you mean change is in acceleration and acceleration? So basically the jerk is in and acceleration. So basically what we said before, right?
Yeah. But to make things even more complicated, when a print head moves back and forth, it's going to create different vibrations. It's not always going to create this one. This is assuming that the print head creates a 60 hertz or so vibration when it stops. I mean, it's a lot more than just that, but depending on how fast your printer moves, it's going to create different resonances. But what we're looking at here is where it achieves the worst vibrations.
So vibration meaning frequency plus amplitude, because what we don't want is amplitude, right? We want to limit the amplitude. Is that correct? Because that's
Right.
what's creating the deformation, right?
So theoretically, you could print fast or like a certain acceleration, and it might not induce certain frequencies.
Hi, Lucifer. Yeah. Okay.
Right.
I slowly start to get it. So for each, so when you're printing, you will have some change in acceleration at different acceleration in different direction, and at each change of these factors, it will make the system vibrate at a certain frequency and a certain amplitude.
Right.
And,
That's my interpretation of it.
okay, and then what we need to know is, depending on how the system move, like the change in acceleration, which direction and which jerk, depending on this, we need to understand how the system react. So input shaper needs to do some tests so that it understand how the printer reacts. Okay.
Sort of, but yes.
Okay, so now the question is, it's testing directly frequencies, and yeah, I'm kind of going back to,
Okay. So
yeah,
maybe let me continue.
Yeah, okay.
So the first thing is to measure the entire range of motion. You know, what would happen. It's essentially analyzing the response of the system. Then it can't just take that and do something with it. It then has to test. So it has 5 different algorithms, and it tests, I believe, every single frequency on each algorithm, and then it figures out where there's the least vibration after applying the compensation. So let me go to this one. This is a good example where it's testing different algorithms, and then it's saying, okay, this one right here is going to give 25% total, not reduction, but less, well, 25% of the total vibration it's going to be reduced. But this one is at 6.4, and this one's at 7.4, and this one here is at 0.4. So how much vibration is being removed at a certain acceleration. So it's doing is it's applying, it's testing all the variables against this feedback, and then it's spitting out a result saying, okay, well, if you use the ZV algorithm and then set it to 61.8, then it's going to produce a vibration of 1.2%. And you can see that with this this dotted line here, or well, the resulting this blue line here. That's the results of what it assumes the resonance would be after it applies that algorithm.
Okay, I mean, this step I think is a little bit clearer to me. The step I don't understand is why we're talking about frequency. That's the step that I have difficulties to understand. Like, why are we testing frequency and dealing with frequencies? That's the part I have difficulties.
So without going into complex mathematics, what's the best way to explain this, chat? Because you have the total resonance of a system defined, and then you're using that data to test against what would happen if you try to apply different cancellations to it.
Oh, okay, there you go. I think that was the message from Incendium that I was looking for. He just put it back. Vibration is dependent on acceleration, etc., but input shaper doesn't need to worry about that, since it can just measure the frequency response. Okay, so the frequency response. So that means,
Do you understand what frequency response is? I'll ask that first.
yeah, it's like, I mean, so far in my mind is like this: you have the tool head is stopped, right?
Yes.
And then you ask him to suddenly go up to 10 meters per second, so that's the jerk, and then tell him to increase at a certain acceleration to a top
Fourier
speed,
transform? No thanks.
and in a certain direction. So boom, suddenly your tool head is going to move, and that will induce a vibration in the system at a certain frequency, at a certain amplitude. Okay.
Yes.
So far, this I understand. So
this chart right here, this plot is that response. So every time it moves, it's essentially creating what would look like this vibration or something similar to that. And what you're doing with the acceleration test is you're moving it, you're testing the tool head or whatever at a certain frequency and seeing how it reacts. And you're able to take all those points and then plot it to create a total
so
a total representation of the system.
can I say the relationship between frequency and acceleration and jerk is that the higher, because it has to be directly related, right? If we are talking about response. So the higher, somehow the higher the acceleration and the higher the jerk and the higher the frequency or something like this, there is a direct relationship between these two, right? It's just
yes,
that
you're applying more force into the system, so you're transferring more. You're just essentially making the amplitude of the vibration higher. Yeah. Chat. Fast Fourier transform. Go.
Yeah, I hope you guys are
PTSD.
not sleeping, because there is the exam at the end of the stream.
Yeah, it needs you to analyze FFT of. I'm gonna give you a printer. I'm gonna give you a graph, and then you have to analyze it.
And by the way, Phoenix Call has confirmed that what is it called already? The power spectral density is more or less the amplitude.
Yes. Yeah. It's a representation.
Yeah. Okay. So I think it starts to be clear. So we test. So from the bottom up, we wanted to test different acceleration, jerk, and direction. From the top down, they are testing frequency, which is the same thing. The frequency is actually in the printer. What's happening is that it's moving the head in at different acceleration and different jerk and in different directions. So the graph you see on screen is on the x-axis. So okay. So now I made the link. So now we test.
Yeah, it's kind of. Imagine if you're trying to balance like a spoon, for example, and if you move your hand back and forth, there's a certain motion in which you move it that would cause the spoon to stay upright.
Mm-hmm.
And that's kind of the same thing. So you're kind of analyzing what would happen if you applied a specific force to the printer, and then how it responds.
Yeah. So okay. I think I get it. And then at the resonance of frequency, then the amplitude, blah, blah, blah. Okay. So what's the next step now? The next step is we know the amplitude force or whatever. We know the power spectral density of each frequency, which is directly related to acceleration and jerk. So during your print, we know that every time the head is going to move in a certain way, we know how the system will respond. We know how the system will vibrate at which amplitude, because that's what we're looking for. Okay, and then from there, okay, and that's the explanation you were talking about, Zombie, is that from there is some algorithm that, depending on how the head will move, they will do something, right? That's what you were talking
Right.
about. They will reduce somehow. Okay. Sverster, if there is a loud noise and you cover your ears, the more you push on your ears, the more of the sound waves you dampen. The pressure you use is your brain doing input shaping math. Okay, let me read that again. If there is a loud noise and you cover your ears, okay, the more you push your ears, the more the sound wave you dampen, the pressure you use in your brain doing input shaping. Oh, okay. I didn't know that.
That gives me another good example. Noise cancellation in your headphones. That's
Yeah,
a perfect example. It's
yeah, this
essentially the
one,
same thing.
yeah, this one I know how it works. I mean, it's easy because it's exactly, yeah. I mean, the relationship to frequency is much easier to make.
Right. And then there's different types of cancellation, different profiles that would let in or out more or less.
Yeah.
Of the certain frequencies. So I think that's what the tests are doing, is it's trying to apply the algorithm, whatever it does, whatever cancellation, with different frequencies in mind.
Mm-hmm. Okay. Yeah, so I think we arrived to the point where the next step is to discuss how input shaping will limit these amplitude movement. But I think we're going to do that in the next one. I think I'm slower and slower to understand, so that means my brain is reaching maximum. My brain is overheating.
Hey, Britt, the rating. Thank you very much. Welcome
Hey,
on in.
Creatrix, Britt, how
Creatrix.
are you? Yeah, I was just saying I'm reaching. My brain is overheating. We just spent 2 hours and a half talking about input shaping. So it's it's overheating. So I think we're gonna go the rest of it. I think we arrive more or less at half, right, Zombie? So we understand what's happening in the system. Now we can talk about input shaping, right?
Right. Well, it's important to kind of know what it's doing, though, and like what the test is producing, and kind of what you would do to compensate. Because once you understand that, I feel like it gets a lot easier to understand what it's trying to do.
Yeah. I think so. That's why I like to have very strong, or at least an understanding of the basic, and then start. Because I mean, theoretically, we still haven't started talking about input shaping. We only talked about what the printer is doing.
Right.
So, yeah.
Yeah. I don't know the algorithm specifically. Like that's a lot of probably math and not useless stuff, but I don't know how relevant it is to look deep into the specific algorithms.
Brain thermal runaway. Yeah, kind of. I need an automatic shutdown. So yeah, thank you again, Creatrix, for the raid. And I think actually, did I forget to put the giveaway?
I think so.
Okay. Oh, I just forget to put the banner. That's why. Sorry. I put the banner back. So yeah, how about we do that? How about we stop a little bit input shaping now because I think yeah, and we'll continue next week. So next week we'll talk about actually input shaping, like what actually input shaping is.
Yeah, we can do this next week.
Yeah, today was more of let's say a background check on what's happening on the printer. But I mean, to be honest, in my opinion, or in my point of view, it was really, really useful. I did learn a lot. I make the right, at least it made my understanding of the 3D printing system better, so that I hopefully will be able to understand input shaper a bit faster than today. Nice intro to waveform.
Yeah, this is like it's a thing. We don't like to talk about this thing because it invokes a lot of stress and PTSD from school, and some people do this as a job, and I feel so bad for you.
Yeah, I mean, okay, so we can. What I was about to say. Yeah, I'm very happy to welcome anyone that want to give some explanation. You can just reach out to me on Discord or or whisper me, and then I will send
Yeah, of
you
course.
the link, and then you can come. That's absolutely no problem. Okay,
I can
so
test.
any other any? Are you going to do the test?
Yeah, it's testing.
Oh, it's testing. It's moving now.
Yeah, it's moving really fast.
Okay. So are we matching the frequency of your camera? Is
Nope,
it in the
it's vibrating. It's not moving. It's just vibrating. It's yeah, it's hard to explain.
But
But
depending on the shutter speed and
yes, so this is the vibration. It's just going up, 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 and up to 90, 100, etc.
okay.
Yeah. See?
Do you have access to the command, to the G-code command that it's sending, or there is no thing like this?
Nope.
No. Okay. Okay.
But that's literally the test. If you want to see it. Oh, look at this. So the acceleration. Oh, okay. So that's exactly what it does. The
Oh, yeah, okay.
acceleration
There
is
you
going
go.
up. Yeah. Okay.
Yes.
So it just increases the acceleration to make this specific frequency.
There you go. Now we have
Neat.
that actual connection.
Because
So
I didn't.
Top down and bottom up has been linked. Congratulations, everyone!
Woo!
After 2 hours and a half.
So
we
what's the
have
start of
finally-
6? Yeah, it starts at like 600 millimeters per second squared.
Awesome.
Neat.
Awesome. I'm just thinking about everyone that are thinking, what are these two nerds?
What is this?
What is this? What are they happy about?
Yeah, you can see that cable kind of shake, kind of vibrate a little bit. I mean, it's very.
Yes, yeah, I can see it. I can see
But yeah,
it.
it is doing something. It is vibrating. So.
Okay, I'm thinking if I create a learning page, I think I will need to teach the basic of engineering. Yeah, I mean, feel free to come on our. We have a Printbuster channel.
Yeah, seriously.
On our Discord, yeah, I mean for real, and where we talk about science. And well, I found this very enlightening. Yeah, I'm very happy that again, no knowledge has escaped this stream. It's only your knowledge that came in, and I try to shape it because I'm good at.
So what's your shaping algorithm?
Sorry?
What's your shaping algorithm? PM? Polymaker?
Yeah. I'm PMing all of your input. But yeah, the fact that I don't know anything makes me asking some question and makes the learning from others a bit easier. But anyway, yeah, thank you again, everyone, for joining today. I don't know if you have any other topic or questions on. Oh yeah, is that the fire car? Oh no, it's another one. Oh nice.
Yeah, just did this one, and this is
Did
the
you
smaller
see-
one with the bearings. So this one uses bearings for the wheels, so they spin a bit easier. So it's more like a toy, and it's significantly smaller, like a lot smaller than the other scale.
Oh, is that on purpose
So-
or?
I think so. He like remixed them so the bearing would work perfectly with like this size wheel.
Oh, okay.
Yeah, this one's a little easier to print, but still pretty cool.
Did you see Disturbed Medic collection now?
What are you saying?
Cars?
Like,
He printed all the cars in.
yeah, that's really cool.
Yeah. So that's for the website.
I know, that's really cool. And Turtle, is it Turtle Man? Has been excited to see the post online because no one's used anything remotely similar to this type of filament. This one, oh man, I still like.
That's the fire car.
Ah,
I love that.
yeah, that's
This is amazing. This
yeah. Like seriously, guys, go buy this right now. Not sponsored. It's. I could just like stare at this all day long.
amazing. Phoenix Call. I hope you learned something new today. Yeah, I mean, you cannot imagine how much I learned today. I learned a lot.
Probably too much.
Huge amount, enough to make my brain burn. Okay, so let's do our giveaway. We have 30 people. Only 30 people.
Wow,
Is that what?
no one's awesome today.
Only 30?
Everyone fell asleep.
Is it?
That's
Oh,
usually
maybe-
what happens. I got messages after my stream like, "Oh yeah, sorry, I just fell asleep halfway through."
Oh, I think it's
Uh,
no. Let me try. Oh, sorry. So
did you
you
not enable it?
yeah, I think something
Oh.
wrong. I had to refresh, so it went from the beginning. So yeah. Anyway, as we
Nice.
were gonna do the draw now, so whoever is here, just be awesome once again. Hopefully, your brain is working a bit better than mine after these 2 hours and a half. And we'll draw in 10 seconds. Draw in 10 seconds. Is there anything new that we can talk about on the Discord? Oh yeah,
Please.
once again, we have our non-English channel. Of course, the French channel is always the most active. For some reason, the French, or at least French-speaking people, are always the most active. I don't know if
They
you
talk
have
a
heard
lot.
the Reddit stuff, like the Pixel thing, where France was the biggest one. So
Oh
yeah,
really?
French people, they are not a lot. The French-speaking people, like maybe, I don't know, 100 million in the world, 120 million, something like this. But they are the most present on the internet.
Canadian store next week.
Maybe, sorry.
Canadian store next week.
Yes, yeah, but Jack, yes. After Paisley's is testing, after Paisley test our Canadian store, once we receive the confirmation from Paisley's, then we'll go ahead with the release. If something wrong with Paisley's, then we'll have to fix it. Okay, so we have French, Dutch, Japan, German, Spanish, Italian, Turkish, Chinese, and Danish. So yeah, feel free to go and join this channel. Okay, you guys ready? So we're gonna draw in. We're gonna do 5, 3, 4, 2, 1, and do I wait the 40? No. 40, come on, 1 and 0. I have some free spool to redeem. I can do that on the Canadian store if you want to. Yeah, if we didn't have stock, then I might not have stock in the Canadian store either. They will use the same warehouse. Congratulations to Salamander UK. Are you here, Salamander UK? Congratulations again. Canadian here too. Network admin, and I run servers. Where is my beta access? Yeah, Salamander UK. I guess you're based in the UK. So congratulations for winning spool. Are you on Twitch? Oh, yeah, you're on Twitch. So bang contact. Oh yeah, there you go. Thank you, Builder's Mark. Here faster than me. So bang contact in the chat to reach out to me. Thank you again, Zombie, for joining and sharing knowledge. I really like the duo of theoretical and experimental. I think that's the perfect duo for the stream for
because I like experimenting. I like testing.
Yeah,
I have to physically do stuff.
So that's the perfect combo. So if you guys like this type of stream, it's every Friday morning. Well, for you, I guess most of you, every Thursday, whatever time it is now for you, evening, I guess.
Yeah.
Yeah. Enjoy the new dual seal color on the website, and
they're amazing, guys. Go buy them.
We'll find someone. Are you going to stream or?
Probably not. I'll hang around the Discord. I have to work. Okay, if anyone knows how to hook up a board like this is an SKR, via UART to a Raspberry Pi, let me know. I'm going to jump on the Discord after this. That's my project for tonight.
I don't know who to raid. Do we go
let me see.
The Jang?
Oh, yeah. There you go.
Go
Who else is on?
Amish
is on. Actually, Amish Ace has been printing. Maybe we read Amish.
Oh, he's printing? Okay.
Yeah.
Amish Ace.
Not right now, but we can kind of force him to.
Okay. Let's raid him and ask him where his printer is.
Exactly. What's the raid message? What?
You go
Show
there
me
and
the
say,
prints.
why are you playing? Where's the 3D print? What are you printing today? Blah, blah, blah. Then let's try if we are able to change his stream, at least for a few seconds, where he changed his camera and he has to show us some prints. Let's see if we can do that.
There we go.
What's the difference between metallic and silk? Metallic is a fine glitter that has been added to the PLA Pro, and the silk is a completely different PLA compound that has that silky effect. So okay, so prepare your best argument for him to stop his video game and show us some print, and then we'll go there. Well, thank you again, everyone, for joining this first 2023 episode of Printbusters. It was amazing. Thank you again, Zombie, for joining. See you next time. Bye-bye. Okay, have you read it properly?
Like it?